In this video, we're going to go through another ecological population sampling method called Mark and Recapture. This video comes with guided notes, so hopefully you have a copy in front of you and you're ready to take down some notes. So we are interested in population densities because, as noted in another video, we want to know how many organisms are in a population, and we also want to know how many are in a given area. This gives us an idea of density. Do we have too many in an area? Is it a healthy population size? How are they doing, etc., etc. So by sampling, we mean taking samples from different parts of the ecosystem in order to estimate the total population within the larger area. Okay, so we can't count all of the squirrels at Perry Farm, but we can count the number in a smaller area and assume that the density of that smaller area reflects the density of squirrels in the larger area. So let's take a look at how many squirrels are in Perry Farm. Actually, we're not going to look at that one. We're going to meditate on these snakes for a little bit. One of the ways that we could use our previous method, the quadrat sampling, was when we were counting organisms that don't move very much. Okay, so milkweed plants, dandelions, fungi, coral, things that don't move very much are incredibly cooperative in ecological sampling. They don't move. You can stand there for hours and hours debating what their numbers are. Organisms like snakes and squirrels and deer, things that move a lot, are a lot less cooperative. So for those, we use a method called Mark and Recapture. Okay. All right, let's move on because this is giving me the creeps. Mark and Recapture method still works with equivalent fractions, as did the quadrat method, so we can apply cross multiplication if we assume that our sampling density reflects the overall density. So we'll go over these terms in just a second. I think it's going to be easier if we go directly into the problem. So let's read this example. 50 deer are captured, tagged, and released. Okay, in this these 50 deer are going to be the M, okay, the marked individuals released. Okay, so we capture 50 deer, we put a little, maybe like an ear tag or something on them, and then we release them back into their ecosystem. Okay, we don't harm them other than maybe piercing their ears, but they will look more fashionable. Sorry, that's probably inappropriate. But there are 50 of these. Okay. Now, we release them back into the ecosystem, and a week later, 100 deer are captured. We go out and we capture 100 deer. Okay. We're not just looking for the marked ones, we're just looking for any deer. Okay. So this is going to be, oops. Oh, it went away. Okay, so we have 50 and 100 deer are the size of the second sample. Okay, so this is 100 here. Of those 100 deer, 25 of them are tagged. Remember, we tagged 50 back a week ago, so 25 is the R, the marked individuals that were recaptured. So 25 over 100 should equal 50 over N. This is our unknown. Okay, we want to know what the population size can be estimated to be. Okay, we have 3 of the 4 numbers here, so let's use cross multiplication. 25 times N should equal 50 times 100. And we're going to do 50 times 10 times 100. All right, if we isolate n the way that we all know how to do from algebra, thank you math teachers, n equals, we divide this side by 25 and we divide this side by 25. This gives us an n of 200. Okay, let's go back to purple here. So then n would be 200. 200 is our total population size estimate. Okay, so what this is saying is that here's our sample, right? We sampled 100, and of those, 25 were marked, which means when we released our 50 marked deer, we were releasing them into a total population of 200. Okay, these densities should equal each other if that assumption is true. Okay, this might take a little bit to process, but I want you to try some of the problems. There's some great ones in the workbook on pages 33 and 34, and they use this Lincoln-Peterson index, which is the M and R and S, and using cross multiplication to determine the n. So go ahead and try those problems and see what you find.